Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. So here is the first question. We're going to start off with some exponential functions today. Let's say I want to solve an exponential function. Let's say I have 3 to the power of 2x equals 5. So notice for this example, the bases are different. I also have an x in my exponent. How do I get x by myself? Hopefully you know this already. I am going to take the log of both sides, specifically the log base 3 of both sides. Log base 3 of 3, log base 3 of 5. The reason I do that, notice the log base 3 and the 3 will essentially cancel out, leaving us with 2x on the left side, and on the right side I can't simplify that. It's log base 3 of 5. I'm going to divide both sides by 2, and I'll get a final answer. I don't think you're allowed a calculator on this exam, are you? Or maybe a scientific one?
We're allowed a scientific calculator, but not a graphing calculator.
Gotcha. So I'm assuming this answer is fine in the final form. You could also probably plug this in a calculator, but honestly, I'm fine with this, and I'm sure your professor would be as well. So the moral of the story, whenever you have an x in your exponent, the only way to solve for it, to get it out of that exponent, is to take the log base whatever of both sides. Now, in this case, we had log base 3. Log base 3 is kind of rare. Typically, we deal with the natural log. In other words, we're looking at functions like this, e to the x squared, something like e to the x squared plus x, let's say minus 4, something along these lines, is equal to, on the right, I'm going to put e to the, let's say, negative 2 power like this. So this is a slightly different example. One thing you can do is you can take the natural log of both sides, which if you remember, natural log is the same thing as log base e. It's called the natural log for a very specific reason, which I'll probably talk about today. But you don't actually have to do that for this problem because we notice the bases are the same, and whenever the bases are the same, you can set the two functions equal to each other, the two exponents, that is. So in other words, I have x squared plus x minus 4 is equal to negative 2. To solve this one for x, notice it's a quadratic. It means I'm going to add 2 to both sides. So x squared plus x minus 2 on the left. On the right, I now just have 0. Now I can factor this. Hopefully you guys are good at factoring. It would be x plus 2 times the quantity x minus 1 equals 0. We get two solutions for this one. X equals negative 2 and x equals positive 1. I'll give you a few seconds to write that down. But again, the strategy for this one, whenever you have an x in your exponent, in this case, the bases were the same, right? We can literally set the exponents equal to each other. But just, you don't have to write this down. I'm just talking out loud. If you have, let's say, e to the 2x equals 5, then you would take log base e of both sides, which is the natural log. Natural log is log base e. So that's what you would do if the bases are different. When they're the same base, you set the exponents equal to each other. Hopefully, that's all review. Now, next thing I want to talk about, this is kind of the hardest case you have with logarithmic functions, and that is, what do we do if we have something like this? Let's say I have 5 to the power of 3x is equal to 25 to the power of, let's say, x squared. This is the worst case scenario. Why? Because the bases are different, and I have x in both exponents. I have 5 to the 3x power and 25 to the x squared power. Here's what I recommend you do for this one. We see that 5 and 25 are like a square and a square root of each other. We are going to use that fact to help us solve this problem. The first thing we need to do is we need to choose a common base. It's either going to be base 5 or base 25. My recommendation to you, always choose the lower base. Choose lower base. That's going to be our common base. In this case, it's 5. So the left side I'm going to keep the same, 5 to the 3x power. On the right, I have 25x squared. So I'm going to rewrite that as 5 squared now raised to the x squared power. So now I have the same base, it's 5, but before I set the exponents equal to each other, remember I have a power raised to another power here. I have 5 squared raised to the x squared power. Don't actually shout this out loud. This is a rhetorical question. But what do you do if you have a power raised to another power? Hopefully we're all thinking it. you're going to multiply it. So it's going to be 5 raised to the 2 times x squared. And that's because a power raised to another power becomes multiplication. So I'm saying 5 to the 3x power equals 5 to the 2x squared power. Now the bases are the same. I can set them equal to each other. I get 3x equals 2x squared. Very nice. Now if I want to solve for x, a lot of people have trouble with this part. A lot of people like to cancel out one of the x's here. If you do that, you're losing one of your solutions. So don't do that. Instead, what we have to do is, since it's a quadratic, again, x squared, we need to get all the x's on one side, literally everything on one side, and 0 on the other. So I subtract 3x from both sides. I get 0 equals 2x squared minus 3x. Now it's still not obvious what we do. We don't need to do quadratic formula. What we're going to do is I'm going to factor out the common term, which is x. So 0 equals x times the quantity, 2x minus 3. That's what's left when I pull out x from both terms. And now I'm going to set both of these terms equal to 0. X equals 0 and 2x minus 3 equal to 0. The first solution's obvious. It's right there. X equals 0. The second one, it's pretty easy to find. I add 3 to both sides. 2x equals 3. And then x is going to equal 3 halves. So this one had two solutions, x equals 3 halves and x equals 0. And again, the strategy, I had different bases and an x showing up in both exponent. I had to take a common base and always choose the lower base. Okay, great. So that's pretty much all I wanted to say on exponential functions. Actually, if I were to say one more thing, this is actually kind of helpful to know. Let's say I have e to the 5x times e to the 3x plus 1. How do I simplify this? Well, if you remember, whenever I multiply things with the same base, it means I'm going to add the exponents. And when I add the exponents, it's e to the 5x plus 3x plus 1. That's just going to simplify to e to the 8x plus 1. This is going to help us a lot when we're taking derivatives of some of these functions. Like imagine if I asked you to take the derivative of these two. Well, I mean, the one function, multiply the two things together. This would be a product rule, right? Because we're multiplying two things together. However, we can avoid the product rule if we know our properties of exponents and we just rewrite it like this. I'll talk about derivatives of exponential functions next, but one more thing first. I want to talk about division now because division's annoying. Let's say I have, one last example, e to the 2x plus 1 divided by e to the 7x minus 4, something like this. How would I simplify this? Well, if multiplication was addition, division is going to be subtraction, and you have to be careful because we need to subtract the whole quantity, 7x minus 4. In other words, what we have here is e to the power of 2x plus 1 minus the quantity, 7x minus 4. A lot of you try and be heroes and solve this in one step. I wouldn't because, well, I like getting the right answer, so I would do this in 2 steps. I write it as e to the 2x plus 1, distribute the negative sign to both terms, so minus 7x, and then minus a negative becomes plus 4 now. And now I can combine like terms. E to the 2x minus 7x is negative 5x, plus 1 plus 4 gives us plus 5. There is the final answer to my question for this problem. Any questions on that one?
Since you had a negative exponent, would you have to bring it down to the denominator?
That's a good question. So sometimes you'll see that in the answer choices. Sometimes you won't. My advice to you is, notice how for this one, it's e to the negative 5x plus 5. Since one of the terms is plus, I would say this is fine. What you really run into trouble is sometimes, depending on who it is, like I would keep this as this answer. Like let's say I had e to the negative 5x minus 5. Then technically what you could do here, since they're both minus, you can factor out a negative sign. You have e to the negative now 5x plus 5 power. And remember what a negative exponent means. It means shove that sucker in the denominator. E to the 5x plus 5 in the denominator now. Again, both of these are correct. Do I know what? I think your professor would accept all of these, unless it's a multiple choice question and you only see this one in your answer choices. So again, why did I put this one in the denominator and not the one above? Well, because it was minus 5x minus 5. Everything was negative. If I so much as have one positive, I'm going to keep it in the numerator all day, every day. Because it really doesn't look that much nicer. Like if I were to rewrite this, what would this look like? Think about this for a second. It would be 1 divided by e to the positive 5x minus 5. Does that look nicer than what we have right here? I don't think so. I think this is just as horrible. So I like both of these. Does that answer your question?
Yes, thank you so much.
Yep, no problem. I'm assuming your professor did not explain this. Why would he or her? They are not paid to teach. They are paid to do research for the university, and that is my on-the-books opinion on that. Don't tell your professor I said that. They're great. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks, everyone. Bye-bye.